Have you ever heard the saying, orange in the morning, sailor take warning, orange at night, sailor delight? And then, have you also wondered, is that actually true? Well, like a lot of weather sayings, there is a grain of truth to it. Another one of my weather sayings that I love is the fact that you can tell the temperature by the number of times a cricket chirps in a minute. And while it's not perfect, if you use a certain formula, you can actually get pretty close to the temperature. And I would say it's similar to this saying that we have right here. Based on if it's orange in the morning, you could have a better indication that you're going to have stormy weather throughout the day. And then if it's orange at night, you could have a good indication that tomorrow is going to be better weather. However, it is certainly not good enough to give yourself a full forecast. Your forecast is based on thousands of observations, computer models, mathematical equations, and then local knowledge and experience. So it does give you a good general idea, but not your perfect forecast. So when it comes to myth or reality, I would say it's somewhere in between. But that area in between, I would say, is what is interesting, and the science behind it is fairly interesting. So let's just break down how this saying came to be, because it is a very old saying. The first instance I could find was actually Jesus says something along these lines in the Bible, that if it's orange at night, the next day is going to be a good day for shepherds or something like that. All right, so just diving into our map here, you have the Earth. That blue layer around the Earth is the atmosphere. And the first thing that we're going to do is draw the sun at noon. Now you think about radiation from the sun is reaching the Earth, and it's coming down like that. And then let's label this little spot where we're standing. Let's say that's some spot in California. Key thing that I want you to see there is that the sunlight is taking a very short path through the atmosphere to that point on the Earth. The reason that's important is because it's the atmosphere that scatters the visible light that's coming from the sun. About 50% of the radiation that comes from the sun is in the visible spectrum, and then of that, the particles in our atmosphere are going to scatter it. So when the atmosphere is very short, you're going to get the smallest amount of scattering, and that is basically why the sky is blue. Not going to go into more detail than that. I've already tried to film this video about 4 times, and every time I tried to go deeper into that, it got way too wordy. So we're just going to quickly continue on here. And we're now going to think about it at, this would be sunset, since it's to the west of our point. And this would be sunrise, since it's to the east of our point. And we're pretending we're in California. Now, at sunrise, you have your light coming through to that point, and you see how much longer the path is through the atmosphere. The same is true for sunset. And in fact, it's about 12 times the distance. So what's important there is that the longer path it takes, the more atmosphere it has to go through, the more scattering is going to happen. So instead of the color you're seeing being blue, that one gets scattered away. And then the only one that's left by the time that light gets to you is orange or red. So how you could think of this is, if you remember some of the wildfires or a day with very bad air pollution, it actually leads to beautiful sunsets because there's so much scattering and there's so many particles in the atmosphere that the visible light coming from the sun, the only color left by the time it gets to you is red. So then it ends up being fairly beautiful. So main takeaway of this slide is the more particles you have, the more scattering is going to happen, and the more scattering that happens, your visible spectrum goes from blue to the oranges and reds. Hopefully that made sense. Let's just move on to our next example here. So let's turn these on. Here's our person standing, and let's say this is the east, and that's the west. So let's think first about a sunrise. So our sun is over here. Okay, so sunrise, and you'd think Orange in the morning, sailor take warning. So what does that mean in this context? Well, let's think about if it was orange in the morning, that means there's going to be a lot of particles in the atmosphere. Which kind of air mass has a lot of particles? Is it a high pressure or a low pressure? You might not know that right off the bat, but you could think back to a day where it looks like there's a lot of pollution in the air. Maybe you're in a valley and it looks very hazy. You can't even see a mountain range across the valley. That's usually your days when it's a big, high pressure. So in that high pressure, there's a lot of, it kind of traps in all your air pollution. It traps in a lot of dust particles. And what that's going to do is take that sunlight that's coming in for your sunrise. It's going to scatter a lot of that, and it's going to make the sky look orange. So why would this mean orange in the morning, sailor take warning? The reason for that is this is a bit of a jump for the early forecasters, but we're going to go with it. If a high is to your east, then there's a good chance that you have a low to your west. And with a low, you're often going to have rain and stormy weather. So why would this mean orange in the morning, sailor take warning? The reason for that is because on average, especially in the United States, weather travels from west to east. So if you see orange in the morning, that means a storm could be moving throughout the day today because the high is exiting, and the high means warm, sunny weather, and what's moving in is going to be your stormy weather. So now, let's take the time to actually break down the other version of this. So now let's look at sunset. And good chance you've already been able to get this. Once again, let's put west over here, east over here. Let's label sunset. So our sun is on the west. And then what's our saying? So orange at night, sailor delight. So if we have an orange sky on sunset, that means there's going to be a lot of particles in the atmosphere. So what kind of air pressure makes a lot of particles in the atmosphere? That's going to be our high. And you think of lots of maybe air pollution, dust, just trapping it all down to the surface like a valley on a day where you have one of those spare the air days. And then the sunlight's going to be coming from the sun to your eyes, being scattered by all that, and that's what's going to make it look orange. Versus what would be over here, which would be your low pressure system. Let's just fill that in real quick. All your rain over here. All right, so what's happening in this drawing? So orange at night, sailor delight. The key thing to think about is weather moves from west to east. So the weather that's going to be moving in over the next 12 to 24 hours is going to be your high pressure, which is warm air, sunshine, and what's exiting is your low, which is your stormy, cloudy weather. So I've kind of said this confidently about where your highs and lows are going to be, but key thing to remember, this is not an exact science. Next time you see a good sunset, it doesn't mean that the next day is going to be warm and sunny. It just means that on average, there is maybe a better chance that it's going to, because that's what the kind of observations humans relied upon for thousands of years before we had sophisticated observations, mathematical formulas, and computer models. Personally, I'm going to stick with the computer models and our high-resolution forecast maps, but hey, if you're stuck in the wilderness and you have no access to technology, maybe this is something you can use to forecast the next storm that's coming in. So overall, when it comes to orange in the morning, sailor take warning, I would say, if I had to say true or false, I would say somewhere in between. Overall, I learned a lot throughout the course of making this video. I hope you learned something too, and thanks for watching.